Hello and welcome to my video on the Nintendo Entertainment System, or NES as it was later known. Okay, so it was first released in Japan in 1983 as the Family Computer, or Famicom as it was known. It was then later released in America on October the 18th, 1985 as the NES, and previewed with a redesigned body shell and joypad design. It was then released later for other regions of the world. So the specs I'll go through now. So the specs kind of changed depending on what region the console was released in. So depending whether it was an NTSC NES or a PAL NES, depends on the speed of the CPU and the refresh rate of it. So I'm just going to sort of go over the general stuff of the machine here. So it had a Rico 2A03 or a 2A07, which was a 8-bit 6502 clone. And again, depending on what region it was in, depends on the speed it runs at. It had only 2 kilobytes of work RAM and only 2 kilobytes of video RAM. So the that 2K of video RAM resides in its graphics chip, the picture processing unit, or PPU. And with that 2K, it uses that to hold 2 tile maps, or up to 2 tile maps, which are called nametables on the NES. And it also can hold 2 attribute tables, which are tables that hold numbers which relate to what palette each tile will be using. And it also needs to hold on to information about what color palettes are using which colors as well. So it has a resolution of 256 by 240. That's both on PAL and NTSC, which relates to 32 by 38 by 8 pixel tiles. Again, because it's an old machine, you can't access pixels directly. You can only display things via tiles. So it could have maximum of 64 sprites, known as OAM on the NES, and you could only have 8 per scan line. Otherwise, the later ones would not be drawn. Sprites can either be 8 by 8 pixels in size or 8 by 16 pixels in size. The NES has a palette that holds 64 colours, but you'll see shortly when I get to it that only 53 of them are actually unique colours as such. The colours are a tricky thing as well. They kind of vary depending on what region, and some clone consoles also have different colours as well and different intensities. For the purpose of this video here, which is geared towards coding for the NES on GBDK, I'll just stick with the palette, which I will show you shortly. So there was 4 palettes for the background tiles. Each palette consisted of 4 colours. One of the colours would be the transparent colour, and then the other 3 would be the sort of main colours. The first palette of the 4 used for the background tiles, its colour 0 was the colour of the background everywhere. and then that colour was kind of shared with the other palettes. Sprites also have a maximum of 4 palettes, but colour 0 in each of the 4 palettes is obviously not drawn and is transparent. It has 5 sound channels in total. 3 of them can be used for tones. 1 is a noise channel, and the other is a channel that can be used for sort of like digitized sound. So more information can be found from the nesdev.org site, which I will leave a link to as well. I'll also post a number of different links about the NES to this video as well, as I will not be diving into loads of detail about the machine. This is literally just to give us a starting point so we kind of understand where we're going with this. So let's get on to the color palette here. So this is a typical color palette here. How things should go is, as you go down the lines here, it should get brighter. So you can kind of think of these as going up in color intensity, if you like. So you would just make up the palettes using these numbers here. And then let's get into the tile data format here. So the tile data format uses 2 bits per pixel. And to draw an 8x8 tile, you have to provide 2 bytes per horizontal line of that tile. So you can, to get the which bits you need to combine to create the bytes, you can literally think of it as putting the switches on, if you like, and then adding those up here. So the way it works is, if you think of these sort of layers, say this image here had all these layers on it. So the color 1 parts here you would put into this grid and add those up, and they would form the bytes in the first row here. And then if you wanted color 2 parts of this image, they would go in the second column here. Hence there's 2 layers, if you like. Now if you had these switches set on layer 1 and the same switches set on layer 2, then that would generate color 3. In the data here, we are only using the 1 color, which would just give us the first line here. So to output data, what you would do is you put all of the bytes that make up the first bit layer, if you like, and then all of the bytes from the second one. Hopefully that gives you an understanding of how we kind of work with these. Now let's get into some of the other things about the NES. So first off, I'll quickly go over, try and explain the attribute table and the sort of name table here. So to draw things on the screen on the NES, you can think of a name table as a grid of 32 by 30 tiles. Now because of the way that the screen was drawn most of the time on old TVs, the top row here, the columns either side, and the bottom row, normally wouldn't be drawn on the screen, but that's obviously not the case with all TVs, so it's a weird one drawing on here. So you would just plot numbers here between 0 and 255 on this grid, and that would represent a tile. Now, what you also have is a thing called the attribute map in memory, and that's where you specify the colours for each tile to use. So the attribute map is only 8 bytes in size. So the way it works is each attribute cell, if you like, maps to 4 tiles in total. So by setting a palette number between 0 and 3 in one of these attribute cells would designate which color palette to use. Now, the thing that makes it even more complicated is one of the bytes that make up the attribute table is actually split into bit flags, and those bit flags correspond to 4 of these 16 by 16 pixel cells. So hence there is 8 by 8 of these cells that make up an attribute map for the tiles, and they kind of look like this. So each byte is split into 4 bit pairs, and then depending on the way you set the switches in each bit pair, that then selects a palette between 0 and 3. So the bottom 2 bits represent the top left quadrant. So if I bring this across here, I'll try and explain it. So the top left would be these 4 tiles here, and then the top right would be these 4 tiles here, and then the left bottom would be these 4 tiles, and then the bottom right would be these 4. So you kind of have to set, if you set 1 byte in this table, it will actually correspond to a 32 by 32 pixel block. So it's a bit complicated setting tile colours on the NES. So yeah, there's that. Now, sprites on the NES, like I said, you can have 64 in total of them. Each sprite has 4 bytes associated with it. One is for the horizontal position, one is for the vertical position, one is for the tile ID. So tiles can be in the range of 0 to 255. And then it also has another byte which holds attributes of that sprite. So the bottom 2 bits of that byte specify which palette to use. So there are technically 8 palettes on the NES. The bottom 4 are used for tiles, and the top 4 are for the sprites. So you would select which palette to use for your sprites using these 2 bits here. The next 3 are not used. Then bit 5 says whether the sprite should be drawn behind the background tiles or in front of them. Then bit 6 will flip the sprite horizontally, and bit 7 will flip the sprite vertically. Now that's all I'm going to dive into here. What I will now jump into is the more interesting stuff. Now let's get to some coding. So I will jump to my NES folder here. And I shall open this up. And then go into some things in here. So you can start with the example which I used from the normal Game Boy. In the make file here, what we need to add are these flags here to target the NES. Now, as I've said many times, if you're working on Windows, make sure you set this to that, if that's where you've installed GBDK. So this is just the path to where you've installed GBDK. This here is set up for where I've installed it on this version of Linux that I'm running on. The ending, obviously, of your file needs to have .nes. Now, in this example here, these are the palette bytes, and this is using the native NES format here. But you can pass it tile data from the Game Boy. As this is GBDK, everything is kind of geared towards the Game Boy, and the tile data isn't that different. Hence, if you've seen my video on the graphics converter for the Game Boy, then you can already create graphics for the NES now. So this demonstration here just highlights what I was saying with the colors. So if I jump back to this, and then a bit of it, this is the emulator I'm using for this. This is the Meson emulator. So it uses the .NET runtime, which you will need to install on Linux. And the emulator allows you to see the tile viewer, sprite viewer, palette viewer, and the tile map as well. And will give you a breakdown of the info on here. So what this is showing us here is the palette data in action. So what I've done here is I've loaded 3 tiles into video RAM, and then I've just drawn the 3 over and over again. Now, one thing you'll need to do when working on the NES is to be careful how much stuff you actually draw at any one time, as in the background there is a buffer which GBDK is using to transfer this data to the NES every time there is a screen refresh. So these commands here set the attributes and then I've used this function here to allow you to easily format an attribute byte. So if I have a quick look at this, using this macro here, we can specify which palette to put in the top left, top right, bottom left, or bottom right of the attribute byte. And this is just showing it in action in this demo here. I'm only doing so although this is only 10 across in here, what this is actually doing, GBDK is converting it to the actual sort of attribute map location. And then what I've also done is scrolled the background down as well. So if you don't do this, then the first 8 pixels will be out of the screen. So these colors here are just references to the palette values here. So using the GameBoy color converter, sorry, the graphics converter that I have, we would be able to design the graphics here, and then you would have to use these numbers here for the palette, not the GameBoy values. So you kind of need to set some additional things up here for working with the NES. So these flags here are literally just telling the PPU that we want sprites to be 8x16 in size, although there are no sprites in this example here. And then we want to switch which bank character data is read from as well. And all we're doing is just drawing some of these out. I'll leave the source code in the link to this video, and I will also leave a number of other links to various resource sites and some other videos which will go into a lot more detail than I'm going to go into here. All I would say is that there are some utility commands in here I've put in already. So for example, set native tile data is what we've what I've been using here, but you can, using this one here, set tile data GB, you can load in a load of GameBoy tile data instead, which is what I will be doing for all of my future videos on the NES, so that I don't have to recreate all the graphics just in a different order when it's exactly the same sort of format as the Game Boys here. I don't think there's too much more I really need to sort of cover here. Definitely have a look through what GBDK's documentation says about the NES, because there are a lot of limitations that will apply. But on the positive note, it does allow you to actually develop for it, and you can make games for the NES now with GBDK, which is good news. So that's it for this video. In the next video, I will, for the NES, I will put a lot more info and go into a bit more detail and provide some new methods for us to work with, and a little sprite demonstration as well. So I definitely recommend installing the Meson emulator. And that's it for this video.